Matt Hardy, the Program Director for Planning and Performance Management here at AASHTO. And I want to welcome everybody to the fourth of 6 asset management webinars that are being sponsored by the FHWA, the Transportation Asset Management Expert Task Group. And I will be talking more about the TAM ETG momentarily, but a few housekeeping things. The topic of today's webinar is on network lifecycle analysis. This is part 2, case studies. We had part 1 back in July, and you can find a recording of that on the TAM website. You can go to tam.transportation.org, and if you click on the resources and then webinars, you can find all of our previously recorded webinars along with the PowerPoint presentations and all that good stuff. And I will also point out that with the GoToWebinar service, I have uploaded handouts. There's a little box, a little area on your navigation bar called handouts, and I have uploaded the 4 presentations that are being used for today's webinar. So if you want anything resource related to asset management, again, I would encourage you to go to tam.transportation.org. Lots of resources there, not just webinars, but access to an asset management TAMP builder, lots of other reports, good case study examples of how other states and are doing asset management. So encourage you to go there. I also want to plug a LinkedIn group. So if you're on the social networking sites, LinkedIn, we have started one on LinkedIn called Transportation Asset Management. Right now it's reserved or limited to public participants. So it's the state DOTs, public DOTs, that sort of thing. Matt Halbrick from Iowa DOT has set this up. And again, if you click on LinkedIn and you search for Transportation Asset Management, it should pop up, and you can make a request to join it, and that'll be approved. Finally, if you have any questions for the presenters during today's webinar, please use the question and answer functionality within the GoToWebinar. There should be a little box over on your navigation bar that says questions. Type in your question at any point, and once we get to the Q&A at the very end, I will be moderating that. And finally, a little bit of phone logistics. We are in what we call lecture mode. So in lecture mode, all of the attendees' lines are muted. We can't hear you, which sometimes is bad because we have somewhat detailed, complicated questions, but many times it's good because sometimes we get put on hold and we don't want to hear your wonderful hold music. So we have put you into what we call lecture mode. So with that, let me move on to the next slide here and talk a little bit about the what this webinar series is, the overall asset management expert task group. So the TAM ETG, again, is pleased to sponsor this webinar. It's one of 6 that the TAM ETG is sponsoring, but this is probably the 20th or something like that webinar that FHWA and AASHTO in general have been hosting since about 2012. These webinars provide an opportunity to connect with the asset management community and then to bring people together around a series of what we think are sort of important topics. Sharing knowledge is a critical component of advancing asset management. And again, in that vein, or to that end, you go to tam.transportation.org. Again, lots of resources that are being shared. So today's agenda, I will first, after I get through with a couple more introductory remarks, Steve Gay from the Federal Highway Administration has a few opening remarks, and then we're going to get into the actual presentations. We have Becky Curtis from the Michigan DOT, Andrew Williams from the Ohio DOT, and then Terry Martin, Ben Hansen, and Tim Skeel from the Seattle DOT. So mixture of DOTs, both state DOTs, and I think I'm really excited to sort of see a city DOT on here. I think this is the first time we've done that, so it's sort of great to get that diversity. And at the very end, again, I will moderate the overall Q&A. So this webinar is being sponsored by the Transportation Asset Management Expert Task Group. It was established to serve as a forum to discuss changes in the way highway agencies are managing assets, and then the structure and membership of the TAM ETG were intentionally designed to ensure interaction with key AASHTO and Transportation Research Board committees. The TAM ETG activities include identifying strategies for advancing asset management practice and influencing change within state DOTs, and partnering with their transportation agencies by addressing gaps in the framework, roles and responsibilities, drivers, tools, and workforce skills. Provides an input to FHWA, AASHTO, and TRB regarding direction, definition, processes, tools, and templates associated with implementation of state and local asset management plans, and then developing and implementing a plan for communicating the work of the TAM ETG to the transportation community. The next in-person meeting of the TAM ETG will take place November 17th and 18th in St. Paul, Minnesota. Anybody is welcome to attend this. So if you're nearby, if you're in the area, please feel free to stop in on those 2 days and sort of take a listen, participate in the overall discussion. And then membership it includes representatives from the federal, state, and local agencies. And this slide here lists who those members are. Tim Henkel from the Minnesota DOT, he's one of the assistant commissioners there, is the chair of the TAM ETG. And then we have folks from New York State DOT, North Carolina, Michigan, Utah for the state DOTs. And then we have international representation from the IPWEA, the International Public Works Engineering for Australia. Chris Champion, who used to be the executive director, is a member. And then Mo Lally from the Alberta, Canada. We also have MPO representation, Chris Avilla from the Waco MPO, very involved in AMPO. And then we have research through Omar Asmati from the Iowa State University. And we also have liaisons from a number of key partner organizations, including FHWA, AMPO, myself, AASHTO, TRB. We also have FTA. I forgot to include them on this, but their FTA is also involved. And we also have representation from various offices within FHWA. So the Office of Infrastructure, where Steve and Nostron work, the Office of Transportation Performance Management with Francine Shaw-Whitson, and then the Office of Planning. It's not Egan Smith anymore, it's Dave Harris. So I need to update this, but Egan moved on to I think the ITS Joint Program Office, but we have a new person from the FHWA Office of Planning. I think this just sort of goes to show the diversity and the different areas that asset management touches. It's not one sort of siloed program. It's very much cross-cutting, and I think that's reflective here in the membership. Finally, just a plug for the TAM ETG webinars. We've had 3 already. On March 11th, target setting and TAMs. Had one in May on Asset Management 101 for MPOs, the 2 on Network Lifecycle Cost Analysis, and then in November 11th, Optimization and Cross-Asset Allocation, and then January of 2016, Integrating Asset Management into Agency Processes. I will note that the November 11th date is Veterans Day, so we're going to have to change that. I'm not sure. We kind of screwed that one up a little bit, but we will modify that one and let people know what the new date will be. We don't want to do it on a federal holiday. The last thing I will note is that the TAM, the 11th Transportation Asset Management National Conference that is sort of hosted by TRB and sponsored by a number of other organizations, including AASHTO. The 11th one is going to happen July 10th through the 12th, and that's going to be in Minneapolis, Minnesota. I think either right now or soon to be will be a call for abstracts and presentations for that conference. We're going to be organizing tracks and all that good stuff. So if your organization, if you're a researcher or whatever, if you have an idea for a paper, for a presentation, please look for that call for papers, call for presentations, and submit them by the due date. I think the due date is going to be later in October, so I just wanted to make a plug for that. With that, I'm going to turn it over to Steve Gay from the FHWA Office of Infrastructure and Asset Management. I forget the exact title, Steve, but if you have a few things to say.
Hey, thank you there, Matt. So a very good introduction there. Talk about the ETG and ongoing activities. Quick comment. I don't often get asked, well, when's the final rule coming out? I want to thank everybody for providing comments to the notice proposed rulemaking. At this time, we are analyzing comments. No date has been set for the final rule, but as soon as one set, you can find it on the U.S. Department of Transportation's website. Has a section there that pertains to rulemakings with dates and all that sort of thing. So I expect something in the next several weeks. Also, please visit the FHWA Asset Management website. Just Google FHWA Asset Management. We posted a couple publications about a week ago dealing with financial plans. The third one should be posted shortly, and we're reviewing a fourth. This pertains to asset management and financial plans. I think this will be important as your organization is developing this. Also on the FHWA Asset Management website, we often get asked, who's the contact in the state DOT, or how can I reach person X and statewide? You go to the top there, has a section on who we are, and it has a state contact list there. So I'm excited to hear the presentations today. I think the bottom line is investments, managing for the whole life, how to best allocate money, the risks involved, etc. All the key items from an asset management framework. Just continue to go back to this, what you see on the slide. This is how we do business. Preserve our assets and minimize their whole life costs, operate in a financially sustainable manner, and provide a framework to improve performance on a long-term basis. I think as we listen through these presentations today, we're going to address all those issues. Thank you so much, and back to you, Matt.
All right, thanks, Steve. All right, so first up in our presenters today is Becky Curtis from the Michigan DOT, titled her presentation, Network Lifecycle Analysis for Bridge Management. Then we do a quick introduction for Becky. Becky is the Bridge Management Engineer for the Michigan DOT. She provides engineering and administrative oversight to the operational aspects of the department's annual bridge program, development of bridge management systems, development, maintenance, and communication of bridge strategy, and performance measures in accordance with Michigan DOT strategic plan, state goals, and objectives. This includes bridge program management, bridge management systems, bridge load rating, and special structures design. Becky also serves as a member of the AASHTO Bridge Management Software Task Force, and Becky is a licensed professional engineer in the state of Michigan. I am going to hand it over to Becky in just 1 second. All right, and Becky, I'm going to give you control. And you should be, whoops. All right, Becky.
All right. Well, good afternoon, everybody. And as Matt said, my presentation is going to try to tell the story of how Michigan has implemented life cycle cost analysis at our network level to better manage our inventory of bridges. So with any good story, we need to set the background for the primary conflict within our plot. And this slide is sort of the MDOT bridge program's version of "It was a dark and stormy night." So in 1998, MDOT was very near the bottom of the country with respect to the percentage of state-owned structurally deficient bridges that we had within our inventory. So then in 1998, that's when MDOT began our commitment to asset management. In combination with an increase in our state highway funds, we committed to sound asset management practices and the ability to report on performance. Goals were set for each of our programs, and for bridge, we set the following goals. So first, we have to immediately address the needs of 100% of our structures of critical concern. As safety must always be our primary goal, it's important to recognize that, so that despite your best efforts of asset management, either limited resources or unforeseen events can cause situations which require either restricting a structure, performing repairs, possible replacements, and accounting for this when you're setting your goals is going to give you a more realistic picture of what your needs are. So the primary condition-based goal for MDOT that was set in 1998 was to achieve 95% of our freeway goals in good or fair condition by the year 2008. This condition was measured based on the minimum condition rating for the National Bridge Inventory components, so your deck, superstructure, substructure, or culvert ratings, where any of the ratings of 4 or less would be considered poor for the whole structure, 5 or 6 would be considered fair, and 7 through 9 are in good condition. The secondary goal was to achieve 85% of the non-freeway bridges in good or fair condition, also by 2008, using the same NBI minimum condition rating scale. So how did we do? Well, as of 2014, you can see that MDOT is now more toward the middle nationally with respect to the percent of state-owned structurally deficient bridges. The 85% non-freeway condition goal was met before 2008, and so that goal was achieved. The freeway condition has steadily improved over time to really closely approach the 95% condition goal. However, increasing costs and a steady revenue has prevented us from completely reaching that goal. So we would not have been able to accomplish the improvement that we saw, however, without our focus on mix of fixes, a dedicated preservation template, and the ability to justify performing preventative maintenance on our bridges. And that's where the life cycle cost analysis enters into our story. So it may help to understand a little bit about our inventory of bridges within Michigan. Michigan has just under 11,000 NBI structures, of which MDOT maintains 4,450. Our overall state-owned bridge condition is currently at 94.2% good or fair. The majority of our inventory was built between 1958 and 1971, which makes it about 50 to 60 years old on average. MDOT NBI bridges are primarily simple steel or simple pre-stressed concrete structures. Operationally, the structure at MDOT is a decentralized agency, and we are divided into 7 regions. So while the overall network of bridges is managed centrally in my office, each region manages the bridges, including performing inspections, scoping for project selection, and determining which project should be included within the 5-year plan for their inventory of bridges within their region. And then in addition to the state-owned structures, our local agencies maintain 6,541 bridges at a condition of 85.3% good or fair right now. So getting into the network analysis, 2 possible ways to categorize the asset management for our bridges is at the network or the project level analysis. At MDOT, we use both types of analyses. For our network analysis, we use the National Bridge Inventory minimum condition ratings, or like I said previously, the lowest condition of either the deck, superstructure, substructure, or culvert ratings. And using an internally developed spreadsheet, the Bridge Condition Forecasting System, or BCFS for short, we calculate the probability of deterioration, compare it to the investment in projects on our bridges, and use that to predict future network condition levels. We use the network analysis to manage large populations of bridges at one time and to help allocate funding at the region level. We also use this forecasting tool to provide high-level information on our condition, and that information is often very useful for our executives, the legislature, and the State Transportation Commission. At MDOT, the project-level analysis is more specific to each bridge. So in that case, we use the National Bridge Elements and have historically used Pontus and now AASHTO bridge management software to forecast conditions at a specific bridge based on element condition. We use the project level analysis to prioritize between possible projects, to manage specific bridge elements, and to provide useful information to our bridge engineers and bridge practitioners. So in order to effectively manage our network of bridges, we find it very helpful to have accurate data that's readily accessible by all the people that are going to be managing them. At MDOT, we have a web-based inspection and reporting system called MyBridge. MyBridge allows our inspectors to enter both the NBI and the element level data in the web-based system. MyBridge also allows the inventory to be viewed quickly on the dashboard, which provides condition information and sorting functions, and these directly connect to our condition-based goals. This allows the person performing the analysis of their network to evaluate network level condition while still being able to quickly drill down to the bridge level. So using the data that is entered into MyBridge, I populate the Bridge Condition Forecasting System, or BCFS, with this information in order to predict future condition. So being in an Excel spreadsheet form, BCFS is easily editable and can be modified to meet a variety of different uses, which I'm going to give an overview of shortly. So in its typical format, BCFS does require some input. So you need to start with your NBI conditions of your inventory, which is going to be the starting point of your analysis. BCFS also requires budgets that are entered to account for the work that's going to be performed on your network of structures. The budgets can be entered as $0, of course, for a do-nothing strategy. BCFS requires that you identify what your preservation strategy is, or your mix of fixes, which it then uses to dedicate a percentage of the budget to each primary work category. So at MDOT, these categories are preventive maintenance, rehabilitation, and replacement. So replacement projects typically focus on poor bridges, which relates, again, to a national bridge inventory minimum condition rating of 4 or less. Rehabilitation projects, such as concrete overlays, for example, they focus on bridges with minimum condition ratings of 4 through 6, while the preventive maintenance focuses on ratings of 6 through 8 in order to delay future deterioration. Project costs for each of those primary work categories must be entered so that the program knows how far the budget in each category can go. We typically use the average of the last 2 years' cost for the work category to arrive at this number. The next input is the preservation path, or what the anticipated benefits of each main work category is going to be on the bridges that are used based on your budget. And then finally, BCFS allows you to enter your program projects if you want, leaving the budgeted portions for only the outer years that are not fully programmed. So the cornerstone of the Bridge Condition Forecasting System is the transition probabilities. Using the changing minimum National Bridge Inventory condition ratings over time, BCFS calculates the likelihood that a structure is going to change from one minimum condition rating to the other. A matrix is developed from our historic inspection data, and then that matrix is applied to the entire network of bridges to project the condition out to each successive year included within the analysis. So this image shows the transition matrix. The probability of a condition rating not changing is shown in purple. The average time in a rating is shown below that in gray, and then the cumulative time to reach a certain rating is shown in teal. So for this population of bridges, the predicted time to pour, or the time it would take to reach a minimum condition rating of 4 or less, is 43 years. So BCFS is also a tool to track deterioration rates, or the number of bridges within a network that fell into the poor category each year. This is not forecasted data, but rather is recorded historical data. Once all of your inputs are populated, BCFS calculates the projected condition. This is a combination of both the deterioration lowering your condition, and then, on the other hand, your programmed work based on actual projects, your budgets, preservation strategies, and the preservation path increasing or maintaining conditions. In this example, our inventory is split into freeway and non-freeway in order to match our condition goals, but really the network could also be examined in any category that you chose, such as NHS and non-NHS, on-system and off-system, or your entire network together. The analysis of freeway and non-freeway protections has been used here at MDOT as part of our call for projects process in developing our 5-year plan. So as I mentioned previously, selecting bridges for the call for projects process is done at the region level. However, determining the initial bridge strategy for each region is performed centrally based on our inventory, and that's updated each year. So funding within the bridge templates is then allocated to each region based on need. And using this initial strategy, the region evaluates the potential projects being planned and then the impacts on the future condition as compared to that initial strategy and also an ideal strategy. As the bridge programs coordinated, of course, with the road and safety programs, the actual program selected for bridge is going to differ from the ideal. But BCFS allows the bridge engineer to predict the impacts of selecting those various projects and can use that in justification of whether or not a project should continue. So using the historic and predicted data, the Bridge Call for Projects Subcommittee reviews the region strategy, the projects, and the progress towards goals, and then provides recommendations for the approval of the projects or modifications to the selected strategy. So it's in this way that we integrate our network analysis into our project selection. Another way that we utilize BCFS is in the demonstrating the value of preservation. So this is an example of the flexibility that I find in using an Excel spreadsheet to perform our network analysis. So I was posed a question by the chair of the Transportation Asset Management Council in Michigan. What would have happened if all of our local agencies had not begun to adopt bridge preservation and instead had continued down the path of worst first? Well, by running BCFS scenarios, I was able to model this situation. So the top line is the measured condition. As the Transportation Asset Management Council was able to communicate the benefit of preservation to our local agencies, more preservation projects and rehabilitation projects were selected, which prevented bridges from falling into lower conditions. This slowed the deterioration rates of the local bridges over time, as you can tell by the improvement in condition. The darker lower line is a condition that was predicted by the model using the actual budgets in the years under review, but using the transition probabilities that were in place before the push toward bridge preservation and a mix of fixes. So the difference in the condition versus the measured state and that predicted in this chart is just one more tool that can be used to communicate the value of preservation and asset management. Another very common use of BCFS within our agency is to evaluate the impacts of changing funding. Budgets can be impacted, of course, as funding is shifted between road and bridge, for example, or if our total funding is increased or decreased as funding builds and revenues change. By running our different scenarios, the impact of those increases or decreases in funding can be quickly identified and displayed in a way that is really easily communicated to our decision makers, such as our executives, the legislature, and the State Transportation Commission. So in this case, on this slide, there are 3 different scenarios that were modeled within BCFS. One was maintaining a current program at the time. Another was the impact of an additional $60 million of funding per year for the bridge program. And the final was if the bridge program was reduced due to lack of funding. And you can see the impacts of those decisions based on the change in condition after 10 years. So another example of how we use BCFS and our network lifecycle analysis is in the evaluation of innovative materials. Bob Kelly from my office took our basic BCFS approach and modified it to divide the network into 2 pools over time. All of the bridges start off in the main pool, but when they're replaced, they are moved into a second pool with lower deterioration rates. And this is supposed to reflect the benefit of the innovative material. So the network condition at any point is simply the sum of what is in each pool. Simulations were analyzed for a few sample assumptions to demonstrate the process, where both the replacement cost was varied and the deterioration rate was varied, ranging from 1.5 times the cost of a conventional bridge with 1.5 times the life, all the way up to 2 times the cost of a conventional bridge and 2 times the life. The scenarios assumed a budget which was sufficient enough to correct most condition deficiencies in the short term. And when the effect of the discount rate starts to cut into the number of projects that you are able to perform in a year, the condition starts to go downhill, which happens at a rate around 10 to 15 years. Since it takes a while to build up a population of the more durable bridges as they're more expensive, then you don't start seeing the benefit of building the longer lasting bridges for about 50 years down the road. So until then, you pay a small penalty in network conditions because of the slightly fewer projects, but by the time you get 50 years out, those investments start to pay off. And so this is an example of how when an innovative material with an assumed addition of life can be evaluated to see how long we need to make that investment before we start to see the benefit. So in addition to performing network analyses with our current data, MDOT has also performed studies to develop guidelines for use in project selection by our regions. As deck conditions tend to drive a majority of the project selections within our state, the focus was on developing a preservation matrix for decks. The original matrix was created a few years ago, but using the transition rate calculations within BCFS, MDOT very recently reevaluated the time to pour for decks with black bars, with epoxy-coated reinforcement, with stainless steel, and with fiber reinforced polymers. So the black bar results are used to provide guidance on the timing of preservation actions on our existing bridges, while the epoxy-coated, stainless, and FRP results will be used both to provide guidance on existing bridges as well as to develop use cases for when it's cost-effective to use the longer life materials such as stainless rather than epoxy-coated reinforcement. Creating this document allows all bridge decision makers in Michigan to benefit from our network analysis without having to actually run the analysis themselves. So to use this chart, the decision maker looks at the condition rating in the upper left for both the top surface and the bottom surface based on NBI condition and also percent of deficiencies. And then you follow the correct row over to identify the repair option. And we also provide then the potential result of the repair and the anticipated fixed life of the repair. And then looking ahead, MDOT's interested in performing multi-objective network modeling. We hope to incorporate additional risks beyond merely just deterioration to analyze our bridge network and to perform similar analyses that I mentioned previously, including the expected performance based on existing budgets, identifying required budgets to meet performance goals, identifying the benefit of innovative construction methods for materials, and developing preservation guidelines for use in project selection. We've made steps in the right direction through a scour prioritization analysis, which we plot the vulnerability versus the criticality of each bridge in the network. And what we're looking forward to is including this into our deterioration analysis at the same time in order to come up with a multi-objective optimization. And that's all that I have to present. I believe the questions are going to be handled at the end of all the presentations.
That is correct, Becky. Thanks a lot. I'm going to. All right, next up, we're going to have Andrew Williams from the Ohio DOT. Let me pull up Andrew's slide here. Let me give Andrew control. And let me do a quick introduction. Andrew Williams is the administrator of the Office of Technical Services at Ohio DOT, responsible for infrastructure management, overseeing various operations such as geographical information systems, the highway performance monitoring systems, traffic monitoring, and asset management. Andrew has a BS degree in Industrial and Systems Engineering from North Carolina A&T State University and a master's degree in leadership from Duquesne University. So with that, I will turn it over to Andrew.
Hey, thanks a lot, Matt. Really appreciate it. Rebecca, great job in your presentation. I got a couple of questions that I'm probably going to call you and ask you in terms of your Markov transition matrices. But anyway, good afternoon, everybody. Look forward to having this little discussion with you. I'm going to take a little bit of a different approach to talking about life cycle analysis. We talk about it, we look at it from a standpoint of design, building roads and bridges and those kind of things. What we found out here in the state of Ohio as we put together our asset management plan is that there are a lot of things that we just did not know. So I'm going to talk to you from a perspective of looking at whole life cycle management, but putting the pieces in place to understand what's going on in your own state before you actually dive headfirst into the life cycle cost analysis. So I'm going to take a little bit of a different approach to this today. Okay. What we found out is that 93% of our time and resources is spent taking care of what we have. That basically means that we're not building a lot of new stuff. Most DOTs are in the same position, so we're not creating a bunch of brand new designs and things like that. We're really trying to hone in on taking care of what we have, and our asset management plan actually reflects that. A little bit about Ohio. We've got 43,000 miles of roads. That does not include the urbanized roadways that is controlled by or managed by our locals. When we add that together in terms of state miles, it would come up to about 50,000 lane miles. And then we've got 14,000 plus bridges that we deal with and about 80,000 plus culverts. Just to kind of give you an idea of the size of the network that we have. Wanted to show you a little bit about the how Ohio is laid out. We have 12 districts. I put this up also because I wanted to make sure that as I go through, I'm going to talk about our District 1 and our District 3. District 1 is in the green. District 3 is left blank. But we do have 12 districts, and I want to talk to you in relation to that, spotlighting those two districts. So what are we doing? We're fostering more consistency across our districts. Our asset management plan is actually doing that. We're building collaborative project selection process, building optimized investment strategies. We're utilizing the Dayton pavement management system to do that, optimize run, identifying the treatments, and development of our work plan. And then we're going to help ensure that our statewide goals are achieved. Straddling the life cycle cost piece, we're removing the artificial distinction between capital projects and maintenance activities. We don't want these siloed areas working on the assets as they've been doing before. If you're talking about whole life asset management or life cycle costs, whole life truly means whole life, cradle to grave. So we're focused in on bringing those two entities together. Instead of having two work plans, one that's capital-based and one that's maintenance-based, we're going to have one plan. And then coordinating preservation activities through our planning department. We're actively doing that right now, as you'll see with the upcoming slides, and then using performance data to guide funding allocations. We have a three-pronged approach. We're going to use state-of-the-art technologies such as our pavement management system, our transportation information mapping system that allows us to bring all of our different asset inventories together and do analysis off of it. Aggressive preservation treatments. We have not been very aggressive on the preservation side. Most of what we do have been overlays. Well, now we've introduced the preservation treatments in terms of chip seals, micros, smooth seals, and thin overlays. And then more collaboration. We're going to center ourselves around the life cycle portion of it to try to make sure that we understand what we have not understood before. So with that, the chip seals, again, the District 1 that I showed you on that map, District 1, they do their chip seals themselves, and they're doing them for roughly about $4,000 to $5,000 a lane mile, if you can believe that. They're excellent at doing it. They've been doing it for a while, so they are a poster child for how to do chip seals. So we're going to take advantage of that, not saying that we're going to do most of our chip seals in-house. We're not. We're going to contract a lot of it out, but where we have that expertise, we're going to utilize that. Now let's jump into the life cycle portion of it. We have developed a transportation asset management decision support tool. And that tool allows us to look at our data, for example, our pavement data, and actually learn something from it. And again, these are things that we really didn't know. So when we start talking about the life cycle in terms of how long your treatments last, you really need to dig in and understand what's really going on in your state. Across the top of this, you'll see our districts, 1 through 12. On the left-hand side, excuse me, is some attribute data that we have captured, and we can see exactly how these things are performing. So that first line, that first row there, second row in the district, that is the prior to pavement condition rating by district of every one of the routes that they did from a chip seal perspective. So as you can see, our District 1, they normally hit those routes with a chip seal at a PCR value of about 80, and then all the way across. If you look at our District 3, they're doing them at a 64.7, all right? Now, if you go all the way down toward the bottom, you're going to have an age at repair and an age at next repair. The age at the time that we hit that section of roadway, the previous treatment was about 8 years old in District 1. It was about 9 years old in District 3. We put that down. We are forecasting that the age at the next repair is going to be 5.9 years for District 1 and roughly about 4 years in District 3. So basically 6 and 4. So when you start talking about the life cycle, you look at this chart here, and what stood out to us was that it was highly variable, okay? So we knew we needed to dial it in to get more consistency in terms of what we were doing from a chip seal standpoint and all our preservation treatments. So what we did was we actually came up with a decision tree that is tailored to these preservation treatments, looking at the distresses, also looking at traffic and a few other things, and that's what the districts are using within the Dayton DTAM system to predict where or identify where we want to do these preservation treatments at. But this was very telling in terms of trying to identify what we would get out of our chip seals if we were to do them or place them on certain roadways. Also to spotlight the fact that we have varying different decision-making processes in our district that we need to dial in. On our overlays, here's our thin overlays. Again, looking across the gamut, you see our District 1, they were performing these at a 78 PCR, which is more in the preservation location. And you look at our District 3, they were doing a lesser treatment there. And then as you go down toward the bottom again, what you'll find is the thickness removed and the thickness added. So the on average, District 1 was doing 1.4 inch overlays, which is pretty typical for our thin overlays, 1.5 inches. But then you look at our District 3, they were doing thin overlays also, but they were also putting them on pavements that were a lesser PCR. So the life that we would get out of them is 8-point-something years versus, about 6 years. So imagine doing an overlay on a roadway, and every 6 years you're going to have to do another overlay at a cost of about $150,000 a lane mile. So what this identified for us was that there was some savings that we could have if we were to introduce these preservation treatments, but not only just introduce them, but when we start talking about whole life, introduce them in a way that gets us more consistency, putting them on the right pavements. But how do you put them on the right pavements if you don't understand the performance of these treatments in and around the state that you're working in? And so, for example, we're thinking that we're going to get about $1 million, about $600,000 savings on just one section of roadway by using the preservation treatment, putting the right treatment at the right time, but understanding how it performs. We're utilizing the Markov transition matrices as our forecasting tool. We're actually forecasting individual distresses. So it allows us to run that decision tree out in the out years to identify what kind of candidate treatments we're going to do in the future. So that's where we're going to get our savings. We're also estimating that we're going to save about roughly 10 to 15% of our capital program. Our capital program is $2.5 billion, so you can guess that our executives have their ears wide open in terms of hearing that kind of savings. I honestly think we're going to get there. so that we don't leave out the maintenance side. Now we're merging capital and maintenance. This slide here, again, coming from our asset management decision support tool, what it shows us is the red line there up at the top is our performance. That's our payment condition rating performance. Our scale is 0 to 100, 100 being perfect. The blue bars are our capital investments. You'll see one in 2006 on this roadway, there was a bridge. One in 2009, that was an overlay. And then you'll see the orange bars. Those orange bars are for maintenance. That's where we had a maintenance expenditure. Now, the key thing to look at on this particular chart is to look at the capital investment over that 15 or that 13-year period, the capital investment and the maintenance investment. The capital investment was about 1.8 million. The maintenance investment is 1.2. And then in the 2013, we spent about $325,000 on that roadway doing maintenance. And I highlight the chart off the side that the tool allows us to click on that bar, and it gives us that result on the left-hand side. So as we can see, 80-something%, close to 90% of what was spent that year in maintenance was done in pavement. So now you're starting to ask yourself the question, okay, whole life, whole cost. What is the cost over time that I'm spending on this particular asset? I should be able to learn from that to figure out what type of treatment I'm going to do in the future to make sure that I can get the desired life I want to get. Again, we feel like we're going to be able to save by looking at the whole life of these assets and drilling into what we're spending capital, what we're spending maintenance, and what the problems are that the dollars that we're spending are supposed to address. So that's how we're taking the approach to dealing with life cycle, a whole life cycle of the analysis. And one thing I do not want to leave out, the payment management system does a very good job of going through the decision tree. We have another tool that we use within the decision support tool called identification of poor performing payment sections. That terminology, or it is defined as the number of treatments that we do on a payment section over a certain period of time, say 20 years for the life of it. Also, the number of deterioration, the deterioration rate, and the number of times we meet that deterioration rate. So, for example, here in that District 3 where we're showing that we're not performing that well, we are identifying those routes over a 20-year period where we had accelerated deterioration, that's PCR drops that are greater than 7 PCR points per year, 3 times over the life of that. And also looking at the number of treatments where we had 3 or more treatments over that 20-year period. Because what that tells me is that the pavement's not performing well, and also I'm spending a lot of money. So if I've got 3 treatments in a span of 20 years, that's not a very good life cycle. So we've set up the tool to be able to identify those so we can pull those out separately, address those, and then put them on a preservation mode going forward. We've introduced this concept, and what we've done is that the payment management system has identified the treatments, and what you're looking at here is a breakdown of those preservation strategies over time, everything from the chip seals all the way out through our major rehabilitation. As you can see, the lion's share of our mileages are in the chip seal, microsurfacing, double microsurfacing, and our smooth seals, or our fine-graded polymer asphalt overlays, which are the lesser costing applications or treatments. And then you can see we're doing very little in terms of the major news, and then also in terms of the minor rehabilitations. We're going to keep our good pavements in good shape. We're going to monitor how we're managing those from a standpoint of maintenance and capital projects. And then we're going to use the state-of-the-art technology from a data analysis standpoint, identifying how to treat the roadways and prioritize our highest benefit at a lowest cost. I'm not going to speak about the bridge side of it, but we are just going to mention the fact that we do have preservation treatments that we've identified for bridges also. That would include bridge cleaning. It would include sealing the decks. It would also include sweeping our bridges. We feel like we're going to get a lot of bang for the buck out of that, but of course it's going to take some time for us to see those results. But we have introduced those treatments already. They are included on that one work plan to identify those types of activities. from a capital or maintenance standpoint. Collaboration, which is huge. The capital and maintenance work plan, again, under one plan. Continuous interaction with our frontline crews and our local governments and contractors. Everybody's in this. We're going to manage this thing holistically from top to bottom. And so our frontline folks who are out there seeing everything from a day-to-day, we're taking their comments and including them in the decision-making process in terms of identifying how we're going to handle those. For example, if the pavement management system identifies a project that's going to be done, let's say in 2018, typically we were doing worse first. Now we're saying let that really bad pavement go for another 2 years. Our maintenance folks, our frontline crews, are the ones that are going to step up, and they're going to pick up the slack and hold that project, that segment of roadway together until we actually get to the capital project. We've termed that a gap project. So our frontline crews are identifying where those gap projects are at. The example I showed you earlier where we were spending about $280,000 a year maintaining that roadway so that it was serviceable, what we might find out is that that's too expensive for us to do that with our frontline crews. That project then would get moved up, pushed over to the capital side, and then the capital side would actually program that in to the DTAM system. So that's an example of how we're going to make that work. And then capturing, analyzing, and replicating success statewide. I showed you those charts where it showed that our District 1 seemed to be doing a very good job of reserving their pavement asset at a very high level, a very high serviceability rate. We want to learn from that. And so we're going to learn from the maintenance side. We're also going to learn from the decision-making side how we're going to manage the whole life of that particular asset. Communication plan. What we found is that if we were going to do this, a collaboration is good, but a collaboration is only as good as people understand it. So what we've done is we put together a full blast communication plan that includes fact cards, FAQs, talking points, the elevator speech, a video, web page, PowerPoint. This will get pushed out to everybody within the DOT internally, and it will be done at varying different levels. So, for example, our highway technicians, who are frontline folks, they will have a different version of this elevator speech as it pertains to them, our planning and engineering side, all the way up to our executive management. On the external side, in terms of introducing new preservation treatments and managing the whole life of the asset, we felt it very important that we communicate with the industry because we have not done a lot of chip seals and we have not done a lot of micros. We want to make sure that the industry can handle all those miles that we showed you that we're going to do chip seal and micro surfacing, and also to reassure them that the program is not going to really change other than the fact that we're going to be doing some different treatments and give them time to actually get geared up to be able to do that. And then lastly, be able to communicate the direction that we're going to our legislator and ultimately to our public who are actually paying for these investments to show them that they're getting a good return on their investment. So again, we are taking a little bit of a different approach to the life cycle cost analysis portion of it, recognizing the fact that we did not know a lot of things about how our assets were performing, and to take care of that part first so that we can truly affect the kind of change we want and get the desired results that we wanted to get. Thank you for your time, and then I'll turn it over to Matt for the next presentation.
Great, thanks, Andrew. Up next, and our third and final presentation is from the Seattle DOT contingent. So we have three folks from Seattle talking about their risk-based approach to managing arterial pavements. First is Terry Martin, who is the Asset Management Program Manager for the Seattle Department of Transportation. He has 25 years of private and public sector civil engineering experience, including 13 years of experience working in water, wastewater, and transportation asset management. And helping him out, or included as part of that presentation, is Ben Hansen, who's a civil engineer in Seattle DOT's pavement management section. And he's worked in pavement design and pavement management since 1998. And finally, Tim Skeel, who has over 30 years of experience in applied economics, including asset management, life cycle cost and benefit cost analysis, resource planning, modeling, econometrics, utility rate setting, and utility finance. He received a master's degree in economics from the University of Washington in Seattle, Washington in 1983. And I'm going to turn the controls over to Terry. And I also want to thank everybody. I know that the big Apple event is going on right now, so I think, there's some new iPads and some new iWatches out there. So after the webinar is over, go do your Google searches on the big Apple event, and I'm sure some exciting things will be out there. But for now, Terry, all yours.
All right, thanks a lot, Matt. Hopefully you all can hear me very well. If not, let us know. I'm going to start off with a quick overview, and then I'm going to hand it off to Tim. So what you're going to hear from us is some common themes from the previous two presenters, but also maybe a couple different things. We're a city DOT, so we are dealing with mostly an urban environment, but then also, and maybe kind of somewhat uniquely for us, we are one of the fastest growing cities in the United States. We have been for the last 3 years. So not only are we sort of combining together, that urban part of it, but also we're competing for funds for preserving pavement with all sorts of different other parts of the organization. We have to get 500,000 people in and out of this city every day, and so there's competing funds to reduce congestion and things like that. So preservation funds are competing with planning for new stuff. So first and foremost, one of the difficulties that our paving group has is coming up with a multi-year paving plan. It is a very long and arduous process. There are competing modal priorities. One thing that our paving manager likes to say is that if you asked what are the top 10 streets in Seattle, if you asked 10 different people, you'd get 10 different answers. So we need to come up with sort of an answer for that, which we don't have right now. And then also a pressing concern that we have that I think maybe a lot of places have as well is explaining what this backlog is. We have a backlog of about $1 billion, and we've had a tough time explaining what exactly that means and also what to do with it. So as far as our backlog goes, like I was saying, we have a $1 billion backlog, and it's growing. Most of the value of the backlog is really expensive road reconstruction projects. I think about 1/10 of it is mill and overlay and chip sealing according to our old system. But most of it is these complete reconstruction projects, which if you do a road reconstruction project, you're basically displacing a lot of money that you can use on many other projects. And we have very limited funding. Like I was saying, we're competing with other parts within our own organization for limited dollars. Okay. There's a little bit of a delay on our putting the slides forward here, just so you know. So then the big question is, how do we balance our current paving needs and reconcile all of this existing backlog, all with pretty limited funding? This is a map of Seattle here, and basically everything you can see on this map that is of a magenta color are roads that are part of our backlog. So this is sort of setting the framework here. And with that in mind, I'm going to hand it off to Tim, who's going to talk about this benefit cost-based paving model that we've developed that is actually pretty new. It's still a beta product, and it's been around just only about 2 or 3 months now.
Hey, Tim, it's Matt. So I'll just go ahead and click through it. Something was happening. I heard you clicking. It wasn't working, so I clicked it. So just let me know next slide, and I'll go through it. I'll click it for you.
Okay. Hi, everyone. Glad you've joined us here. Happy to come talk about this. So I have a couple of slides that have a lot of words on them, but the point of having these up here is to say that part of the roadway cost involve the cost to users. And if we're really going to say we're talking about life cycle cost, we should have the pavement cost and the cost to users. So it's been recognized that the impact of poor roads on users drives up vehicle operating costs, and it drives up vehicle operating costs for roads, trucks, and buses anyone who's on the road. So we wanted to take advantage of that to think about, really where would we put our money to the best use? And we're here to serve the people who are using the road, so shouldn't we take their value of use into account in prioritizing which roads we work on first? So, just to say that we can look at this total life cycle cost should include user costs. And next slide, please. And this, again, is a lot of words, just to say that a few examples of a lot of the research and studies that have been done connecting the condition of pavement to vehicle operating costs. And so there's quite a bit of data and research on how the roadway impacts users. So next slide, please. So this is sort of the basis of our model for deciding on which roads should receive the highest priority for funding of restoration of pavements. And we use a pavement condition index is how we measure our roadway conditions, and we have a every 3-year survey of our arterial roads to find out what their condition is. But as you can see here, that the increase in vehicle operating costs as the road condition, our PCI drops below 60 and heads on to sort of the failed condition at 0, what happens to impacts to vehicle operating costs for cars, trucks, and buses. So next slide, please. So this is the very familiar part of pavement cost, the cost of restoring it. And well known that if you get in early and do some preservation and early maintenance, the life cycle cost of that is very cheap. It's a really inexpensive way to lengthen the length of time that you can maintain the pavement's condition. If it drops below, in that 60 to 50 something range, it's obviously dependent upon a particular street, but you're now into a more expensive kind of treatment to restore the condition, and that's the mill and overlay. And the same transition happens if the road falls too far into its condition, then a mill and overlay won't work to restore it, and you're into pavement reconstruction, which is a lot more expensive than mill and overlay. So the next slide. So here, and just to sort of put a framework around this, from an economist viewpoint, cost and benefits, or value and cost, are two sides of the same coin. So I'm turning it around here and say the cost to users of decreasing pavement condition and declining pavement condition can be turned around and say, well, what are the benefits from improving that condition? So here I'm listing them. I'm showing the benefits to road users in terms of vehicle operating costs of restoring the street. And you can see that starting somewhere around a pavement condition index of 60, if you restore the street, the road pavement condition, you'll get a certain benefit. And the benefits climb as the PCI gets worse. You get a bigger benefit if the street is worse than if the street is not as good. Secondly, streets that, and VOC here, and the little arrows and the words saying benefits from reduced VOC, that's vehicle operating costs. A high traffic volume roadway is going to have bigger benefits than the exact same roadway with lower traffic volume. So here's one of our points of saying, hey, how do we know which roads, whether we had two identical roads, identical conditions, everything about them was the same, cost of restoration? Well, we could just look at that and say, well, they seem to be in the same boat. But if one has 3 times the traffic of the other, then its value of the restoration is much higher than the one that has the lower amount of traffic. And we want to take that into account in how we allocate our funds and say, let's not just pick based upon what it costs to restore the road. Let's pick it both on what it costs to restore the road and the value to the users in terms of reduced vehicle operating costs. So this is sort of the basis of our model. And a bunch of implications come from this. One is that if you catch a road early, and the benefits aren't that high, but if you think about, as long as the benefits are greater than the cost, you should do it. If you have, a benefit to cost ratio greater than 1, then you should do that. So streets that are dropping in their condition, below the sort of 60 PCI level will benefit from the cheapest kind of restoration thing with the crack seals and microsurfacing. But once they get beyond that, where that is no longer effective, there's sort of a gap there until that road deteriorates badly enough, or if the traffic is high enough, for it to become worthwhile to spend money on mill and overlay. And again, then there's another transition point from when the road becomes poor enough to no longer be effectively restored from mill and overlay, and we need to go into reconstruction. It's not worth doing it if the roadway isn't deteriorated enough to make the benefits pay off, and also if the traffic is not high. So you can see that, suppose we've got 2 roads here. One is a high traffic volume and one is a low traffic volume street. The high traffic volume street is going to have a higher benefit cost ratio wherever you're looking at it in terms of its restoration compared to the low traffic volume street. Next slide, please. This is the same information portrayed differently on the graph, and what it's showing is the benefit cost ratio. The blue is a high traffic volume street, and the green is a low traffic volume street. And if we were going to do something that would say this would be the optimal treatment, if we had unlimited funds, we would do anything that had a benefit cost ratio greater than 1. That's that red bar that runs horizontally there. Anything greater than 1, we would do it. If it's not 1 yet, we don't do it. So this would show us that there's a lot of streets that we won't do anything with, even if we had all the funding that we could ask for, until they reach a poor enough condition, and we'll be spending more on streets that have high traffic than we would on streets that have low traffic. And we have some more slides here to talk a little bit about the issue of what we call the backlog. And right now, we basically say any street whose condition is below 55 or so is in our backlog. It needs us to go spend some money. This says not necessarily true. There's a lot of streets that the value to users of restoring the street isn't high enough to justify the cost of restoring the street. So we would change our definition of a backlog using this method from what we have now, which is any street in poor condition we're going to spend money on. That wouldn't necessarily be true if we were really saying, let's look at the value to users of how we spend money. After all, we not only have trade-offs within our own agency of where we're spending money on new shiny stuff or trying to preserve what we have, but we're competing with schools for funding locally. There's plenty of good ways to spend money publicly besides on roads. So we would want to do what's the right thing for the community as a whole, not just for how we view it from streets. So we might change the way we define the backlog. Let's see, there was one other point about this I wanted to make. don't remember. Let's go to the next slide, please. Okay, so what we've got, we have a work and pavement asset management system that we have all of our street segments on with data about the street segments, including the condition of the street, you know, the type of pavement, the size of the street, and the traffic on the street. And so we basically have, you know, 24,000 street segments that we would look at. We would compare the present value of the cost of restoring the street with the appropriate treatment that's available to it, to the value of that restoration to users, and get a benefit cost ratio from that. So each street gets ranked by a BC ratio, and we would stack them in order from highest BC ratio to lowest. Actually, go back to the slide before, because the point I did want to make about that was, if we don't have enough money to do all of our streets, and we certainly won't have it, even if we said, hey, we're not going to do streets that don't have a benefit cost ratio greater than 1, we still aren't going to get enough funding to do them all immediately. So really, that red line, we could put it up, you know, to 1.5 or 2, and we would do all of the streets that were above that until we run out of funding, and then, you know, move on to the next cycle. So the other point of this model is to say we can allocate the funding we have, even if it's not sufficient to do everything we would want to do, to the streets that have the biggest bang for the buck, to the users of the streets, the whole point of why we're here. Okay, so go down a couple more slides. One, yeah. So let's just go through and show you an example of a street in Seattle that makes a good poster child for this. So this is a little bit less than a mile of street, and we've been, you know, since 2003, we've scored it 4 times, and, you know, every time we go check the pavement condition, it's in a very poor pavement condition, in the mid-teens, which is basically what we would call failed. We haven't done any work on this street other than sort of work for safety, make it serviceable, so we've filled potholes and we've fixed big cracks and stuff, but other than that, we haven't done anything to it for a decade or more. And it keeps working, right? It's functioning. Cars, trucks, and buses are driving down it. But the issue for cars, trucks, and buses is that it costs them something to drive on poor pavement relative to what it would cost to drive on good pavement. So next slide, please. So here's what the agency, our SDOT, has spent on this street in the last 10 years in pot repairs and spot paving, and a little bit of claim damage. About $63,000 a year being spent to keep this street up. So that's part of the cost that, if, you know, the life cycle cost, and if we were to restore it, we would avoid those costs. So that's part of the cost, but go to the next slide, please. We also have accumulated user costs. So when we look in our model to say, what does it cost users over these last 10 years, and just to sort of tell you a little bit about the data. So, you know, we've got roughly 13,000 cars driving on this road a day, 400 plus trucks, and, you know, 150 or so buses a day. So the vehicle trips per year and the impact on their costs given the pavement condition, about $420,000 a year in additional vehicle operating costs over the last 10 years due to the road's condition. So that is the sort of life cycle cost side of this street in only keeping it serviceable and not restoring it. So the next slide, please. What? Okay. So what this graph shows is that if we look at this road and ask, is it worthwhile to, is the benefit cost ratio high enough to make this street worth restoring? And this street will just make it. If we think about at this point, it's into a reconstruction. Reconstruction's going to be about $10 million, and you know, with its life cycle cost over the next 50 years, about $10 million. The benefits from it, the difference between the restoration condition and the user costs associated with that versus its unrestored continuation of what we've been doing with it into the future, is a little bit more than $10 million. So this one, at a 5% discount rate, just pencils out for us to basically say we should go out and spend some money on this street. Next slide, please. If instead, and I only changed one thing on the model inputs here, and that is I doubled the number of cars, trucks, and buses on the road. If this street were a lot busier than it were, its ranking on this benefit cost ratio would jump way up. So this is kind of our innovation of how to think about the prioritization for our funding, is to say we should spend money where the biggest bang for the buck, not only in terms of the roadway cost, the pavement cost, but of the cost to users. So this road, if it was a lot more busy, otherwise it's the same road, would jump way up in the ranking in terms of its benefit cost ratio. Next slide, please. We've got 5 minutes. I may not be able to make it through all of these. Here's this discussion about the backlog. So right now, anything in that sort of light green shaded rectangle is in our backlog currently, but all of those, all of that road up to that point between PCI of 40 and 22 or something, you know, the way the lines are working out here on this graph, shouldn't be part of our backlog. We would not spend money on it even if we had enough money to spend until they got worse enough to show it. The lower, less steeply sloping dotted green line, such as a non-arterial street where the benefits of restoration are low because the number of users is so low that there really isn't a big cost impact on them. Those may end up, and that's basically what we are doing now, it's our de facto policy, is not spend very much money except for safety filling potholes on non-arterial streets. They're just not worth it in terms of the cost of the pavement restoration compared to the value to the users. Next slide, please. So quickly just going through this, turning it around and saying we've got, we're going to count user costs, vehicle operating costs, together with pavement costs. There's going to be a minimum point on that U-shaped total of those two cost curves, the pavement cost and the road user cost. So for a policy of saying what is our minimum PCI that we should maintain on streets, for a high traffic volume street, the road user costs are very high, and that shifts that lowest life cycle cost minimum point to a higher PCI. You go to the next slide. A medium volume street, as opposed to the high one, has less user costs associated with it. The minimum point on that U-shaped total life cycle cost curve is now at a lower minimum PCI. So we would have a different service level and say, hey, we will maintain a lower PCI because that's where its total life cycle cost minimum is. And finally, the next slide, a very low volume street basically says the road user costs are small enough that the minimum life cycle cost curve just says this road really doesn't deserve very much expenditure at all because it's cheapest just to keep it at a pretty low condition index and not spend. So we would have potentially service levels on streets that would be related to the value to users of the pavement and have a different, essentially, pavement condition that we would maintain for different streets. Last slide, please. So this is just to sort of point that out that depending on how much funding we have, we can shift this line up and down and say we've got service level 1 for our highest valued streets, service level 2, which we may only maintain in some poor pavement condition, and then service level 3. This is just an example. We haven't figured all this out, but we might say, really, we're going to allow these streets to essentially go to what we would otherwise call failed condition. They still work. People still go down them, but they're in really poor condition, and the impact on individual vehicles operating costs is high, but there's just enough on there to make it. So we may have some splitting up of how we deliver service levels according to the value of the road users. And Terry, unless you have points to add, that's the end of our presentation.
No, I think that's about it. Thanks.
Great. Thanks. Let's go to the Q&A here, and then we just bring up the other slide here. So we're on to the Q&A portion. So if you have any questions, please use the chat pod. We have a couple. The first one, we are going to change the date of the next webinar, which is scheduled for November 11th again. That is Veterans Day. The one I think is for Andrew Williams. I know Andrew had to sort of duck out. I'm not sure if he's back on, but it's a question about the communication plan. Yes, yep, we can hear you. So it's a question about the communications plan that you mentioned. Is that available online, or is it can it be sent to people?
Yes, I have no problem sharing.
Well, if you want to send it to me, I can send it out to the folks here that attended the webinar and make it available as a resource when we post the recording and the presentations to the TAM website.
Can I add one item there, Matt?
Sure.
You know, I might have stated this in an earlier webinar. I know the AASHTO Asset Management Guide and some previous documentation from Federal Highway really doesn't talk much about having a communication plan. They touch on it in the Federal Highway publication beyond the short term. But if you look at Britain's Asset Management Guide, they have a chapter on it. And I think two key aspects. It's good to have a communication plan internally so everyone's on the same page, they know their role, and also maybe part of the same plan or separate. How do you communicate externally? And does the top leadership give the same message as mid-level management, and what are the key issues to be made? And I think if you're doing it without a communication plan, it's kind of haphazard. You may not be communicating what you really need to. Or I think even me here in Federal Highway headquarters at times, when I go back and look, you say, hey, I should have done. Having that communication plan can really help you in addressing some of those issues. Back to you, Matt.
Oh, thanks, Steve. And I would just sort of emphasize that communications is a big part of AASHTO has our standing committee on performance management, and asset management fits nicely under that. And a big component of the whole performance management and measures and everything is the communication. How do we take all this data and this information and communicate it, and sort of work collaboratively with the public, the users of the system, to figure out, perhaps what targets do we want to hit, given what our resources are and stuff. So communications, I think, is a very important component to all of this. The next question for Seattle. The next two are for Seattle. One was about the source for the estimated user costs versus the PCI curve. The question is, how was that developed?
Okay. So most of the studies that have been done on the impact on vehicle operating costs use the International Roughness Index as the way of measuring street condition and then measuring the impact on vehicle costs. So because we use PCI as our rating system for our roads, there was a study done that did a correlation between the IRI and PCI, and so we use that model to sort of translate typically the IRI into a PCI number to associate with the increase in vehicle operating costs. The actual increase in cars, trucks, and buses number, percent increase, is primarily from a review of literature that put together the results of several different studies, and is kind of an amalgam of studies that show that there's a range of what they've found, but that's kind of a midpoint. So, and we did a quick does this make sense? And thinking that a car that if you drove 10,000 miles a year and your costs were increased by 30% or 40% is roughly the range of it, driving on really poor streets versus good streets, it's about $350 to $400. That seemed like a pretty reasonable estimate to us too, and that corresponds with what some other studies have said the impact on vehicle costs is from poor streets. So we think it's pretty much in the ballpark, but there is, there are literally dozens of studies that have been done. Some of them very careful scientific stuff. Other ones that were a little bit more using, just data as they could find it. But does that answer the question?
I think so. It's from Matt Halbrick, so if Matt needs to follow up, he's from Iowa DOT. I'm sure that if it's okay, he can follow up with you guys and ask a more detailed question or a follow up.
So there's a TRIP study, TRIP study that's done every year that I think is unique to each city, and I want to say that they said that this vehicle operating cost for Seattle was about $800 a year. So we're starting off a little conservatively, but it is, like Tim was saying, it's in the ballpark.
Okay. So we have two more questions. How do you adjust, so for the Seattle folks, how do you adjust for and I forget what VOC stands for, I know it's not volatile organic compounds, based on pavement conditions. So how do you adjust the VOC based upon pavement conditions?
Well, that's basically what we're just talking about. The VOC is vehicle operating costs. Yep. And so we basically just have a curve that shows cars, trucks, and buses that starts from what are vehicle operating costs with roads that are in good shape, and then which is about, for a car, it's about $1,000 a year average for 10,000 miles a year. And if as the condition worsens, the percent increase in those vehicle operating costs is taken from that curve to apply to the road. So a road that's has a PCI of 10 will have a higher multiplier for vehicle operating costs than one that has a PCI of 50. So it's based on those studies that have shown what the percent increase is, and then it just averages for cars, trucks, and buses, and a percent increase of the poor road condition impact on that. And so it's tires, it's suspension components, it's fuel, it's even car body stuff that the sort of how long of life does your car last, and everything is all impacted by road conditions.
And it's slide number 6 in our presentation is the graph that shows how that's calculated.
Okay. And then the last question, and it's actually the moderator's question, for your arterial, so the map that you showed, like the second slide, had all the roads that you were in charge of, many of them being the arterials. Are there any arterials that are designated as part of the NHS, the National Highway System?
Yes, all of our principal arterials.
Okay, so you guys are in...
Just principal arterials.
Yeah, just all of... Yeah, we have minor, collector, and principal arterials. So I think out of our 1,547 arterial pavement lane miles, about 500 are principal arterials and part of the National Highway System.
Okay.
Yeah, so as deduction from this presentation, those will be, you know, all things considered, because they have the most buses, trucks, and cars on them. As we have limited funding, the money will sort of flow to those roads. That's one of the sort of subtext of this, I guess.
Yeah. I'm just thinking to the asset management plan requirements and the pavement requirements with the NPRMs that came out because of MAP 21, and how the focus is on the interstate and the NHS, and you know, measuring those and sort of reporting up to the national level, and that, you know, that collaboration between the city, like Seattle, and then the state DOT, Washington State, and you know, trying to analyze that data and prioritizing, you know, what projects and everything get built where.
Yeah, I will say one of the issues we have here is that the principal arterials that we have that are part of the National Highway System aren't necessarily all of our busiest arterials. You know, different parts of the city get denser at different times, and so as the years go by, the traffic patterns change and the freight patterns change, and so even though our principal arterials are part of the National Highway System, there are other arterials that actually, you could argue, have more value than some of those principal arterials.
Yeah. Okay. Well, thank you. So that's it's past 3:33. So I kind of, if there are any other follow-up questions or anything that people have, you know, feel free to sort of contact the presenters. I have their information and can get it out to people. But I do want to thank Becky Curtis from Michigan DOT, Andrew Williams, Ohio DOT, and then the contingent from Seattle DOT, Terry Martin, Ben Hansen, and Tim Skeel. Excellent presentations, I think very informative. Really appreciate you taking your time to be part of this. And for all those attending, you can download the slides right now if you want to. We are going to be uploading them to the website along with the recording at tam.transportation.org. Look for our next webinar in November. It will not be November 11th. We'll probably go either the day before or the day after. We just have to sort of figure out some